In this video, we're just going to wrap up what happens with our mass spring system when we have a weak damping force and no external force. So we're going to consider this initial value problem. The first thing we do is find the general solution by finding the roots of the characteristic polynomial. That's what we have for the characteristic polynomial here. We have a common factor of 2, which we can divide out to make it a little bit easier to see what's going on. Then we use the quadratic formula to find the roots. And the expression under the radical turns out to be negative 36. So this is a situation where we're ending up with complex conjugate roots. And those roots are turning out to be, let's see, it looks like square root of 36. I think maybe I had a mistake here with this example. Square root of 36. No, I think it's okay. I wasn't sure at first at this step, but I think it's okay. I think I actually did check this. Hello from Alpha, I hope so. So it looks like those are the roots, and so we're in case 3. Alpha is -1, beta is 3. So there's our general solution. Again, I'm omitting the details of finding C1 and C2. You know how to do that at this point, so you can check that work on your own if you feel like it. C1 turns out to be 5, C2 turns out to be 0 based on the given initial conditions. So that ends up being the formula for your solution to the given initial value problem. The solution is still approaching 0 in the long run, which makes sense physically because we have a damping force. Even though it's weak damping, we still have some damping going on, and there's no external force to provide energy to the system. So it makes sense physically that the solution is still approaching 0. But because the damping is relatively weak, we can still see an oscillation happening. The idea here is the oscillation is happening in our solution, but because the system is losing energy at the same time the oscillation is happening, there's an envelope is what it's called, plus or minus 5 e to the minus t. Your oscillation back and forth is occurring within that envelope. So you still see an oscillation happening, but in the long run, theoretically at least, your solution would pass through the equilibrium infinitely many times, but the amplitude of the oscillation is getting smaller and smaller over time because of the damping.